Hey guys, so we are doing this problem called implement string. Return the index of the first occurrence of needle in haystack from -1 if needle is not part of haystack. So essentially we're given two strings and we have to find if the smallest string is present in the biggest string or not, whether this is a substring of this string or not. Right? Clarification. What should we return if needle is an empty string? That is a great question to ask in an interview. Okay. Propose this problem, we will return 0 if needle is an empty string. Okay. So let's add this condition right away. If needle's length is 0, we return 0. Okay. Now, what is the approach? So we can basically consider all the substrings of length equals to length of needle, right? And then if any of those, basically we'll consider all strings of length equal to needle in haystack and check whether it equals needle. Okay, so let's do that brute force approach. Before that, obviously, if length of needle is bigger than length of haystack, then we obviously cannot be a substring. So let's handle that as well. So let's define these variables. So haystack length and needle length. Okay, and because it is variables, maybe I can just this. And also now we have is if the haystack length, sorry, if the needle length is bigger than haystack length, then also it's not possible. And now what we're doing is we're considering all substrings. So first we'll consider substring starting from first index, and we'll consider substring starting from second index and so on. Okay, how many such substrings are possible? So the last substring would end at the last character of haystack, right? So I mean, if this is the bigger string, then the last, and let's say it's something like this, so it would be something like this. So we don't really go till the end. Okay, so the last substring will go from I to haystack length -1, right? What is this length? Haystack length -1 minus I plus 1, and this will be equals to needle's length. So in this case, I would be equal to, so 1 and 1 gets cancelled. I will be equal to haystack length minus needle length, right? So this is where we put in haystack length minus needle length and I plus plus, and we check if is, this is a substring. So haystack starting at index I is, can we get a substring that matches needle? If it does, then we return true. Oh, we do have to return the index. So this is the first index from where this is a starting point, right? So this is, in this case, when we are starting from this index, we see this LL and that matches. So we return index 2, which is what this would be. If you don't find any substring, we return -1. Okay, let's implement this is substring as well. This is our haystack, this is our start index, and this is needle. And now, because we are handling the conditions here, we don't have to think about edge cases. Hey, needle can be empty because we won't allow it. All of that has already been checked. So we just walk through the list, walk through the strings. I equals 0, I less than needle length, I plus plus. If at any point we found characters not matching, so needle we are looking at this I, and haystack we are looking at start plus I. And if they don't match, we return false. If all of them matches, we return true. Right. So let's run it. All right. Run all test cases. Okay. Submit. It works. But if you look at the runtime, it is not that great. So let's talk about the time complexity here. If n is the length of needle and h is the length of haystack, then there are h minus n substrings that we can compare, and each substring will have to walk through n characters, right? So the time complexity n equals to needle length, h equals to haystack length, then time complexity is h minus n. These are the number of substrings we have to check, and each substring has length n. Right, so this we cannot avoid. These are different substrings we have to consider in the worst case. But if we can get some hint that, hey, you don't need to check this entire string again and again. So for example, let's say if I have the count of all the characters in that substring, and if you see that the two possible combinations that we are checking for equality do not match the same count of characters, or maybe something simpler could be just the sum of the characters. So what I mean by that is, let's take an example. Yeah, so here LL is the string that we are looking for. So if we can build some indication that the string that we're looking for has two L's and that's it and nothing else, right? And then when we start needle, we are looking from the starting index NE, and if we can keep track, hey, this NE contains one N and one E, which does not match two L's. That way we could reduce that. We don't have to compare the string. Similarly, when we go EE, we don't have to really compare EE and LS. We just know the count of characters don't match. The count of characters comparing is a valid one, but they have 26 characters, and I mean we can handle it, but we can also do something more simpler, which could be just add all these character values. So for LL, we know that, hey, L plus L, whatever is their ASCII value, right? And we generate some code out of it. And when you do N plus E, that code has to match this code. For in general, it won't match. It will match only if there's the same number of characters, or it could also match in other combinations, but it will definitely reduce the combinations. So what I mean is L plus L, right, and then N plus E. It will also give some code. Now, there can be hash collisions for sure, where some two characters might actually equal L plus E, but still we won't have to check for each and every substring. It will still, the number of hash collisions won't be that high, right? Similarly, E plus E, and then E plus D, and then D plus L. I missed this L here, and then we look at L plus L. So the point is, if you just know some sort of this code and this code does not match the actual code that we are looking for, then we don't really have to compare. So we reduce these. We reduce these. For this h minus n, only for some of the strings. So it would be like times dot. So how do I explain? So it would be some strings which we won't have to check plus h minus n minus x, in while for other strings we might have to check n times, right? And our target is that we increase x as much as possible, so we reduce this component, and that's where this hash code comes in. So let's try and explain what we mean by this. So let's call uh, let's generate needle. I don't know. Let's call it long. Uh, so needle hash code start with 0, I equals 0, I less than. And we just keep on adding. That's all. So we do. Hmm. Right. And similarly, we generate the first string that we are checking would go from 0 to NL minus 1. So here we add the last character. So except the last character, we can generate so it's uh, so do the same, but we leave out one character for this loop, and so we do this minus 1, and we leave out this one character for this loop. It's called needle. Okay, change this. And so what this would do is 0 to NL minus 2, and NL minus 1 I'll add here, which would be what? So caret I plus NL minus 1, right? And now instead of, we don't have to always check this, we'll only check this if the HayStack hash code is matching needle hash code, right? So this reduces, and if it does not match, then we move on to the next string, obviously. But the first character of this hash code, so what I mean, so we have this n e. Now we want to move into e. So this n has to be removed and this e has to be added. This e will be added here, but this n has to be removed, so that we'll do in the else part. All right. And now again, let's test if there is any compilation error or anything like that. Okay, accepted. Submit. All right, now we can see the time complexity is much better. And we discuss the time complexity here. It would be, okay, yeah, it would be sort of like this. And this x will depend upon we want basically to improve this x as much as possible to make it more sort of linear. Of course, a worst case would still be n square, but average case would be much better. And this x depends upon the hash code. We could maybe use a better hash code than just a sum of the characters to improve it even better. But yeah, this is still sufficient to improve the time complexity. All right.